Hello everyone, welcome to the second lecture on behavioral modeling. Myself R. Bhagyalakshmi, Assistant Professor, Government Engineering College, Hassan. Now let us just preview the topics what we have covered in lecture 1. In lecture 1, we studied about the structured procedures, initial and always, and also we came to know about the blocking assignment and non-blocking assignment statements. So let us continue with lecture 2. So in this lecture, we are going to understand the delay-based timing control mechanism in behavioral modeling, use of regular delays, intra-assignment delays, and zero delays, describe event-based timing control mechanism in behavioral modeling, use of event control, named event control, and event or control, use of level sensitive timing control mechanism in behavioral modeling. We are going to study in detail about all these topics in this lecture. Let us move further. So first let us start with delay based timing controls. What is a delay? Delay is the duration between encountering and executing a statement. So, what's the symbol that is used to specify the delay in Verilog? So, it is ash symbol. Ash symbol is used to specify delay in Verilog. And the specification syntax to specify the delay in Verilog is as follows. It uses the keyword delay, 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 followed by a number. It can be a numeric or a number, or else it can also be a identifier which is specified with a delay number, or else it can be specified with minimum, typical and maximum type of delays. So all the three types of delays can be specified with a separation separated by comma. So this is the specification syntax for delay in Verilog. Let us continue. So at first, delay based timing controls, we have three types of delay. First one is regular delay control, second one is intra assignment delay control, and third one is zero delay control. So let us study in detail about these three types of delay based timing controls. So first one is regular delay control. So what is this regular delay control? Regular delay control is used when a non-zero delay is specified to the left of the procedural assignment statement. It means if we specify the delay onto the left of the procedural assignment statement, then it is called as regular delay control. So let us see how we specify the delay onto the left of the procedural assignment statement with an example. So here we have chosen an example to understand this better. So in the first statement, we have defined parameters by name latency, and the value is equal to 20 here. And also we have specified a parameter by name delta with the value equal to 2. We have declared X, Y, Z, P and Q as registers. And the example begins with the keyword initial. And since we have more than one statement within initial, we have enclosed the statements between begin and end. So here, if we see the first statement, X equal to 0. So here, there is no delay control. It means we have not assigned any delay to this statement. Coming to the next statement. So here we have specified ash 10. So ash is the symbol used to specify the delay and 10 is the number. So here we can find that the delay is specified onto the left of the procedural assignment statement y is equal to 1. So here the delay is specified with a number. and it is equal to 10 units. And in this line, we can observe that. So we have used a identifier latency followed by the hash symbol, so which specifies some delay. So, and we have the procedural assignment statement z is equal to 0. So here, whatever the value latency will take, so the same delay will be implemented or carried on to this statement. Here we can see that latency is assigned with a value equal to 0, and hence in this statement latency will take a value of 20 as assigned in the parameter statement. So the delay counted will be equal to 20 time units. Coming to the next statement. So here P is assigned equal to 1, but we don't have any, we have not assigned any delay here in this statement. Coming to the next statement. So coming to the next statement, hash y, x is equal to x plus 1. So here y is the identifier. So whatever the value y will take, so the same delay will be counted for this particular statement. And in this statement, we can observe that delay is followed by three values. It means that the first value specifies the minimum delay, second value specifies the typical delay, and the last value will specify the maximum delay. So here in this way, all the three delays can also be specified as per the syntax as we have seen. So in regular delay control, the delay will be assigned onto the left of the assignment, procedural assignment statement, where delay can be specified either with a number or with a identifier, or we can specify it as the minimum, maximum, and typical delays. All the three delays can also be mentioned while specifying the delay. So this is how we specify regular delay control in Verilog. So moving on. So let us see about the next type of delay control. So that is intra-assignment delay control. So in intra-assignment delay control, the delay, non-zero delay, is specified onto the right of the assignment operator. So whereas in the regular delay control, delay is assigned to the left of the assignment statement, there's the procedural assignment statement, whereas here delay is assigned onto the right of the assignment operator. So how is the operation sequence here in delay, intra-assignment delay control? Here, compute the right-hand side of the expression at current time. It means whatever the expression we have on the RHS is computed at current instant of time, whereas it defers the assignment of the computed value onto the LHS by the specified delay. It means the expression will be computed, but the assignment is delayed by a specified time delay as represented onto the right of the assignment operator. So whereas in case of regular delay control, the execution of that particular statement will itself be delayed by the number specified by the delay. So here, whereas here computation is done, but assignment to the variable on the left hand side will be done after the specified delay time interval. Let us move on with the next type of delay control. So let us see an example regarding intra-assignment delay control. So here we have chosen an example where X, Y, Z are declared as registers beginning with the keyword initial. Initial loop begins with the keyword begin. Here, X and Z are the two statements assigned with the value 0, but here no delay is specified with respect to these two statements. Here in this statement, we can observe that y is equal to ash 5 x plus z. Here we can observe delay is specified onto the right of the assignment operator. So here computation of x plus z will be done at current time, whereas assignment of the computed value is done to the variable on the LHS after the delay of 5 time units. So the same code is also equivalent to the code as shown here, where we will assign the computed value of x plus z to a temporary variable, and then we assign the value what is present in the temporary variable to the variable y after 5 time units. So this part of the code can also be written in this way, where the simulation or the result will be one and the same. So in intra-assignment delay control, we assign the delay onto the right of the assignment operator. So this is very important here. So moving on. So next type of delay control is zero assignment delay. What is this zero assignment delay? So here in zero delay control is a method to ensure that a statement is executed at last. So whenever we specify delay with zero number, then that particular statement will be executed at last. So with respect to all other statements. So let us see an example here. We have initial, begin, where x and y are assigned with values 0, that is initialized with values 0. So we have one more initial loop. Here the two statements x equal to 1 and y equal to 1 are preceded with a 0 delay. So ash followed by 0. So we'll specify the 0 delay control. So when a statement is assigned with 0 delay, then the statement will be executed at the end. So all the statements which are specified with 0 delay control will be executed at the end of simulation time. So here the four statements x equal to 0, y equal to 0, x equal to 1 and y equal to 1 are to be executed at simulation time 0. But however, x equal to 1 and y equal to 1 have the delay associated with them, that is ash 0. So they will be executed at the last. So thus at the end of time 0, x will have value 1 and y will also have value 1. So in zero delay control, the statements associated with zero delay control will be executed at last. So let us move further. So next topic of this lecture is event or control. What is this event or control? So sometimes it is necessary that the program execution will depend on multiple signals. So when we have to combine multiple signals, so that we need to control the execution of the statement, which is depending on more than a single signal, then we use event or control. So this event or control, it is expressed as or of logical events or signals. Means when we want to combine more events or signals, then we combine them by using this keyword or. The list of events or signals expressed as an or is also known as sensitivity list. Means when we combine more than one events or signals, so we combine them by using the keyword OR. So let's see an example here. So always at reset or clock or D. It means that the statements within this always loop will be executed whenever there is a change in any one of these values, any one of these signals or events mentioned in the sensitivity list. So at least if one of the signal will change, then obviously the statements within the OR loop will be executed. Even if there is a change in more than one signal, also the statements within the always loop will be executed. So whenever one of the signal will change, then program simulation will enter the always loop here. So here within the loop, we have a if statement, if reset. If reset means here we have not specified whether its value is equal to 1 or 0. If it is not specified by default, it means that if reset equal to 1, then the true statement will be executed. So if the value of reset is equal to 1, then Q will be assigned with 1 bit binary 0. Else clock if clock is equal to 1, then Q will be assigned with the value that is present in the variable D. So in event OR control, so if there is a change in any one of the signal or more than one signal, then the statements within the loop will be executed. So when we have to check the condition for more than one signals, we use this event OR control. So in event-based timing control, so change in the value of register or net will be considered, and it is used to trigger the execution of statement or block of statements, either a single statement or the behavior or the action of more than one statement. So that is a block of statements can be controlled by event-based timing control. So there are four types of event-based timing controls. So first one is regular event control. Second one, named event control. Third one is event OR control. And fourth one is level sensitive timing control. So these are the four different types of event-based timing controls. Let us understand these types of event-based timing controls one by one in detail. So first one is regular event control. So in regular event control is specified with the symbol at symbol followed by a event. So how do we specify the events here? So here event will specify any particular event with respect to which. So whenever there is a change in the value of that, but whenever the event is satisfied, then the statements within the loop will be executed. Either a single statement or a set of statements will be executed. So let us see few examples with respect to this regular event control. So here you can see the first example at clock at clock. So as we have come to know, at represent is the symbol for regular event control. At clock means when clock is equal to 1. So it means when the value of clock is equal to 1, then the statement Q is equal to D will be executed. So coming to the next example, at pause edge of clock, it means that whenever there is a positive transition of the clock, so pause edge clock is the event, at is the symbol. So whenever there is a transition of clock from 0 to either logic 1 state or the unknown state X or the high impedance state Z. Then whenever the signal does change from 0 to any one of these values, then it is called, then the statement Q is equal to D will be executed at neg edge of clock. So similarly, when there is a clock transition to logic 0, then this statement will be executed. Similarly, Q is equal to at pause edge of clock D. So how is this execution of this statement different with respect this statement which we have already seen? So here in this statement, D is evaluated immediately and assigned to Q at the positive edge of the clock. So here the value of D will be evaluated immediately, whereas assignment of Q will be done at the positive edge of the clock. So here the at symbol is used to specify the event control. So statements can be executed. Statements can be executed on the change in the signal. So, or at a positive or negative transition of the signal value. So, the statements in regular event control will be executed whenever there is a change in the signal value, or either during the positive transition or during the negative transition of the signal value. So this is about regular event control. So next, let us move on to named event control. In named event control, the event does not hold any data, and a named event is declared by the keyword event, event, and an event is triggered by the symbol hyphen followed by the greater than symbol. So this is the symbol used to trigger the event. The triggering of the event is recognized by the symbol at. So let us see an example with respect to this named event control. So here uh, we have chosen an example, always at pause edge of clock. Means the statements within this always loop will be always executed whenever there is a positive transition of the clock. Begin will begin the always loop if last data packet. If last data packet means if this condition is satisfied, then the event is triggered. So here we have used a symbol to trigger the event. What is the name of the event? Name of the event is received data. So whenever this condition is satisfied, last data packet is being received, then the condition is satisfied and the event by name received data will be triggered here. So what is this event received data? So whenever uh, the event received data is triggered, then always at received data. So there is a change in the event mentioned in front of always at there, which is specified in the sensitivity list. And the statements following this always block will be executed once this received data event is triggered. So here received data is a named event which will be triggered with the symbol uh, as shown here. So this is how we can trigger the event by using named event control and the symbol that we need to use to trigger the named event. So let's move further. Next one is event or control. So here in event or control, it is used to trigger a block upon occurrence of any of the set of events. So either when we have a set of events depending on which the execution of the statements is controlled, then we use this event or control. The list of events are called as sensitivity list. The keyword used for this event or control is var or. So here we can see the example. Always is a keyword, always at represents the event. So here we have reset or clock or D. So we have three events here. We have combined three events by using the keyword or here. So whenever there is a change in any one of these specified events, then the statements following this always loop will be executed. So if reset, if the value of this reset is equal to 1, then the statement following if will be executed. Else if clock, it means when clock is equal to 1, then this statement will be executed. So this is one type of event-based timing control. The last one is level sensitive timing control. So what's this level sensitive timing control? So just now we came to know about event-based timing control. So in event-based timing control, so here it will wait for triggering of an event, whereas in level-sensitive timing control, it will wait for certain condition, that is on values or levels of the signals. It will wait for the certain condition so that the further statements will be executed. What is the keyword that is used for level sensitive timing control? Keyword WAIT, wait, is used for level sensitive timing control. So here we have a simple example. Always wait, count underscore enable. It means wait until this count underscore enable is equal to logic 1. So once it makes a positive transition, so whenever its value is equal to 1, then the further statement in front of wait will be executed. So in level sensitive timing control, so it will wait for certain condition, so that once the condition is satisfied, then the statements further to the keyword wait will be executed. So these were the different types of event-based timing controls. So let us go through the summary of the topics what we have discussed in this lecture. In this lecture, we discussed about delay-based timing control, event-based timing control, and level-sensitive timing control. So these are the three ways of timing control and execution order of statements in Verilog. We also studied about regular delay, zero delay, intra-assignment delay, and three types of uh, which are the three types of delay-based timing control. Also, we studied about regular event, named event, and event or, which are the three types of event-based timing control. Also, we studied about the wait statement, which is used to model the level sensitive timing control. So these were the different types of delay based timing controls what we have in Verilog. So let us see few MCQs to check the understanding of the topics what we have discussed in this lecture. So first one is at pausage means we have four options here. Option A, transition from 0 to 1 x or z. B, transition from x to 1, that is unknown to 1. Transition from high impedance z to 1 or x, all of them. So here, as per the knowledge what we have gained in this lecture, so this is the correct option or this is the correct answer. So at pausage means the transition from 0 to either logic 1, x or z. any one of these states. So moving on to the next question. What is the order of execution of the below code? So what's the code? We have module 0. Module is a keyword followed by name of the module. So register ABC. ABC are declared as registers, and we have done initialization of three statements: A equal to 1, B equal to 1, and C equal to 1, which are associated with zero delay control. So here we have one more initial block which has initialized the variable C equal to 0. Next initial block with the statements assigning A equal to 0 and B equal to 0. So here, what is the order of execution of the statements given here? So we have three options here. First one is zero delay control statement is executed first. Zero delay is executed only after all other statements are executed in that simulation time. Delay statement is non-deterministic. So here, um, since the statements associated with zero delay control will be executed at the end of simulation time, so option B is the right answer here. So let us move on to the next question. An event is triggered by which symbol? So whether equal to, greater than, or this symbol, or at symbol, or none of these. So as we have come to know, event is triggered by this at symbol. So this is the right answer. Next question. In regular delay control, where is the delay assigned with respect to the procedural assignment? Option A, before. Option B, after. So in regular delay control, we always assign the delay onto the before the assignment statement. So option A is the correct answer here. Let's move on to the next question. In intra-assignment delay, where is the delay assigned with respect to the assignment operator? Whether it is assigned to the right of the assignment operator or to the left of the assignment operator. So here it will always be assigned to the right of the assignment operator. So this is a minor typing mistake. So here it will be assigned onto the right of the assignment operator. So whereas in case of regular delay control, it will be assigned onto the left of the uh, assignment statement. Coming to the next question. Which type of timing control is used when it is required to trigger a block upon occurrence of any of the set of events? Whether it is option A, regular event control, B, named event control, C, event or control, or level sensitive timing control. So whenever we want to control the execution of statements, which is depending on more than a single event, then we use this event or control. So option C is the right answer here. So moving further with the next question. In named event control, which is the symbol used to trigger the events? So option A equal to, option B double equal to, option C at symbol, option D. So this one. So we have come to know that this is the symbol which is used for named triggering the event in named event control. So option D is the right answer here. So coming to the next question. What is the Verilog keyword used for level sensitive timing control? Wait, or and. So wait is the keyword which is used for level sensitive timing control. So this is our LMS team, and these are the references which we have referred to prepare this LMS presentation. Thank you for patient listening. Hope you have understood the topics we have discussed in lecture 2. Let's meet in the next lecture. Thank you.